We're going to continue to talk about our exponent rules today. When we raise a power to a power, you will notice that we have a exponent, and then outside of our parentheses we have another exponent. This looks a lot like the distributive property, which is exactly what we're going to do. We're going to multiply that outside exponent by everything inside. So this is going to become a to the m times n. When we have multiple things inside of our parentheses, we talked about yesterday, if you have no exponent, the exponent is 1. So you would distribute your exponent to everything inside. So again, we're still distributing. So this is a to the n times b to the n. If we're dividing, we have exponents of 1 still, but you're going to distribute on the numerator and the denominator. So a to the n over b to the n, and that's what we're going to practice with today. So when we open up our foldy to raise a power to a power, we're going to keep the base and we are going to multiply our exponents, whereas before we we added. So if you look at this example here, x to the third all to the fourth, well, what that's saying is x to the third, we're going to write that 4 times. So we can see that we have 1, 3, 6, 9, 12. So this is 8x to the 12. We can also say x to the 3 times 4 to get x to the 12. If we have a product to a power, so we're going to multiply. Product means we're multiplying. So we have multiple things in our parentheses. We are going to multiply or raise both factors. Factors are the things that we are multiplying, the two parts of the multiplying problem, and we're going to multiply our exponents. So we can see here we would say f to the 3 times 7, g to the 5 times 7. Because really what this is saying is write f to the third 7 times 3, 4, 5, 6, 7. We really want to do that over and over. 3, 6, 9, 12, 15, 18, 21. Whereas our shortcut is saying f to the 3 times 7, g to the 5 times 7. I'm not going to write g to the 5th 7 times. And we can simplify this to get f to the 21, g to the 35. When you have, if you look at this example, number 6, notice there's no exponent on that 4. On 7, there's no exponent on the 2. And number 8, there's no exponent on the -5 or the y. You're going to want to put those 1s there because you're going to have to multiply that. 3 times the 1 times the 2 times the 9. 5 times the 1 times the 4 times the 3. 2 times the 1 times the 6 times the 1 times the 8. That way you can simplify that correctly. If we're going to raise a quotient to a power, we're going to raise both the numerator and the denominator to the power, and we're still multiplying those exponents, okay? Because whenever we have a number outside of a parentheses, that essentially tells us we're going to distribute. If there is no exponent, we're going to put 1, and then we can say x to the 6th over y to the 6th. Same thing down here, we would put 1s here. Now this one, when you have a whole number, this becomes 1 times 2 is 2, 1 times 2 is 2, 1 times 2 is 2, but you can simplify this to 49b squared over c squared. Okay, so remember, if you don't have an exponent there, you're going to want to add that 1 because that is our exponent. Same thing over here on number 6, we were multiplying. This becomes 4 to the third, r to the 2 times 3, s to the 9 times 3. So 4 to the third, you could use your calculator, which is 16 times 4 is, I believe, 16. My calculator is not right. It's 64. And then we have r to the 6th, s to the 27th. Okay, so I'm going to ask you to take these rules, and I'm going to ask you to do 2, 3, 4, 7, 8, 11, and 12, and tomorrow we'll come in and we'll look at them together.